Hi everyone, this is the solutions video for the week 4 review and preview, sections 5.1.2 through 5.1.3. The first one says make a graph of y equals 1/2 times x minus 3 cubed and then graph its inverse on the same set of axes. So looking at this one first, there's a couple of ways you can go about it. I think what I want to look at first is just making the other equation. So if we, making the inverse. So if we think really quick, we've got the original and we need our inverse. We've got an x, start with x. So what's happening to the x here? Well, it's subtracting 3. So I'm going to put a minus 3. And then it's cubed. And then remember, timesing by 1/2 is the same thing as dividing by 2. Okay, so if we go backwards, we've got times 2, opposite of cubed is the cubed root, and plus 3. So our inverse equation would be the inverse of f of x would be equal to 2x, got the cube root, and plus 3. Okay, so really quick, let me write this in purple just so I can keep things kind of together. We've got our inverse. And plus 3. Okay, so looking at the original, let's make a table. We'll do the table for the original. And then we can start thinking about the table for the inverse. All right, so I'm going to make an x and y table. And what I did was I went into Desmos, I typed in the original, and then I clicked the gear so we could have a table, and I did the values 1 through 6. So it gives me some points to plot. I can see my graph here. I can see some different points, so let's go ahead and make a sketch of this graph and fill in that table. So we've got 1 through 6, and we've got -4, -0.5, 0.5, 4, and 13.5. Okay, so I'm going to go ahead and plot that. So we've got 1 and -4. 2 and -0.5, 3 and 0, 4 and 0.5, 5 and 4, and 6 is a little bit too big to get that value there. So I'm going to go ahead and just do a little, do a little sketch. Okay. All right, now to make the table inverse, I could go and plug in that equation and also find table values, but what we learned in this section is that we can actually flip them. So we can go ahead and reverse the table values, and it'll be the same thing for the inverse. So here, I'm going to take this -4 and put that for x, and then that'll be 1. Then -0.52, 0, 3, 0.54, 4, 5, and 13.5, 6. Okay, oh, sorry, it's being a little glitchy here. All right, so then I've got points to plot here, so we're almost done. -4, 1, that would be right here. -0.5 and 2 would be right about here. 0, 3. Then we've got 0.54. 4, 5, and then 4, 5, so that's kind of over here a little bit. And that's really the only points I can fit on this graph, so I'll go ahead and make a sketch. Oops. And there we go. So let's make sure we followed all the directions. We made a graph, and we graphed the inverse on the same set here. So that's all we've got to do for this question. All right, so write the inverse equations for each of the following equations. So we've got these equations. There is a new method that we learned in the third section in 5.1.3. I'm going to continue with the old method here and then do the new method later in the assignment. So we've got, let's go ahead and talk about our original and the inverse. Okay. So the original, we'll start with x, we times by 3 and minus 8. For the inverse, we start with x, and let's go backwards, so that means we'll plus 8 and divide by 3. So I'm going to rename our original equation f of x, so we can label our new equation, and that's going to be x plus 8, and that's all divided by 3. For b, let's do the same thing. So we'll start with x. So it looks like here we're dividing by 2 or multiplying by a half and adding 6. So backwards would be minus 6 and times 2. So our original equation, I'm going to rename that f of x is equal to 1/2 x plus 6. So our inverse of f of x will be x minus 6, and that's times 2. So it's times 2 for the whole quantity. And then the last one. Okay, so we start with x. It looks like we're adding 6 and dividing by 2. So the inverse of that, we've got our x. Looks like we're going to be timesing by 2 and minus 6. So I'm going to rename our original equation f of x. And then the inverse of f of x would be x times 2 minus 6. That would be 2x minus 6. All right. Number 3, A through D, so it's just asking us to multiply each expression. This is kind of a review a little bit from concepts we've learned this year. So I'm going to go ahead and do the box method for this problem. So I'm going to make my box, and then I'm going to put an x and a 2, x and minus 7, x times x is x squared, x times 2 is 2x, negative 7 times x is negative 7x, and negative 7 times 2 is negative 14. Writing out each of these here together, and then combine the like terms. And I am done. All right, B, same idea. Let's make our box. I've got 3m and 7 and 2m and minus 1. So that would be 6m squared, 14m minus 3m, and negative 7. Putting those together, we've got 6m squared plus 14m minus 3m minus 7. Put the like terms together, so we have 6m squared plus 11m minus 7. Okay, remember x minus 3 squared, that's the same thing as x minus 3 times x minus 3. So I will make my box. So that's x squared minus 3x plus 9. Writing it out, x squared minus 3x plus 9. Put our like terms together. All right. And last but not least, we have 2y and 3, 2y minus 3, so that's 4y squared, 6y, negative 6y, and negative 9. When I write these out, we have 4y squared plus 6y minus 9. So notice when we do 6y minus 6y, that's 0. So we're just left with 4y squared minus 9. And there we go. Okay, a little bit more review and preview. It says perform the indicated operation to simplify each of the following expressions. In some cases, factoring may help. So here we're multiplying these two expressions, and if you remember what we learned a few weeks ago, we can start canceling. So like these x plus 2's cancel. Anything divided by itself is 1. These cancel because they're equal to 1. So it looks like we're left with this x minus 3 over x minus 4, and there's still that x there as well. So we've got x minus 3 on top, and then I'm going to put the x out front, x minus 4. Okay. All right, here it looks like we might have to do a little bit of factoring. If I factor the top here and split up my x's, what multiplies to be 6 but adds or subtracts to be 5, I think that would be plus 2 and plus 3. X squared minus 4 factors to be x plus 2, x minus 2. So that leaves us with x plus 2 times x plus 3 all over x plus 2, x minus 2 times 4 over, and I'm going to put x plus 3 in parentheses. So let's start doing a little bit of canceling here. These cancel, the x plus 2's cancel. So all we're left with is 4 over x minus 2. Okay, so for part C, we've got 2x over x plus 4 plus 8 over x plus 4. Remember, when we're adding, they have to have the same denominator, which these do. So we're able to add just the top and combine the denominator basically into 1. Now, we could technically be done, but this top part here could be factored, so I'm going to change that. I'm going to factor out a 2, so it's x plus 4. So the x plus 4's actually cancel, so we're just left with 2. Okay. And for letter D, we actually don't have the same denominator here, so there's a certain way I like to set it up. I like to take x, and then I'm going to put that in parentheses, and then 1 over x plus 1 in parentheses, and write them vertically this way. And we need to do changes so we can make them have the same denominator. So I'm going to rewrite the x and the x minus 1, and I'll rewrite the 1 and the x plus 1. So what I need to do is I need this x minus 1 here. I need that also to be here and here. So I'm going to multiply it to the numerator and denominator of the other fraction. And then same thing here, I'm going to multiply this denominator to the numerator and denominator of the other fraction. So that basically puts an x plus 1 here and here, and an x minus 1 here and here. Okay. Now that we have the same denominator, we can combine them, but rewrite the top, so that's x times x plus 1. We're minusing 1 times x minus 1, all over x plus 1, x minus 1. We can do a little factoring here, or distributing. So we've got x squared plus 1x minus 1x plus 1, all over x plus 1, x minus 1. These cancel. So we're left with x squared plus 1 over x plus 1, x minus 1. Okay, here, solve the system of equations below. What is the solution? Ella, hold on. Sorry, you guys, I've got a new puppy here. Solve the system of equations below. What does the solution tell you about the graph? So I'm going to go ahead and just put these into Desmos. Ella, come here, baby. So x minus 2y equals 7. Negative 3x plus 6y equals 33. So let's take a look at these for a second. Take notice that they don't have, sorry, just checking on puppy. They don't intersect in their parallel lines. So it says solve the system. So because I solved this by graphing, I can see that they don't intersect. So that tells me that the graphs are parallel and do not intersect. To solve a system of equations, they need to intersect. So since these don't, that means that there's no solutions. So I'm going to go ahead and go back to my document here. Ella, come here. And it says the graphs are parallel and do not intersect. The system has no solutions. Okay, and the next one says calculate the x-intercepts for the graph of each function below. So when we calculate the x-intercepts, just type into Desmos and look to see where they intersect. So for this one, you'll see they intersect at 2, 0 and negative 1, 0. And make sure you try this, like type it in, see if you can figure that out. And we've got, for this one, negative 5, 0 and negative 3, 0. Okay, so for number 7, find the inverse of the following functions. So what I'm going to do for these is solve with the new method where we're going to change x and y, okay? So I'm going to make a little note here, interchange x and y and solve for y. Okay, so this becomes x equals y squared plus 3, and we're going to go ahead and solve for y. So I'm going to start with subtracting 3 on each side. So that leaves me with x minus 3 equals y squared. To get rid of that squared, we take the square root. So this becomes the square root of x minus 3 is equal to y. Now we could leave it like that, but technically when we're solving square roots, that would be plus or minus in front of it. Okay. Letter B. So go ahead and we change up x and y. So this will be x equals 1/4 times y plus 6 cubed. And we're going to solve for y. The first thing to do is we're going to take the cube root to undo that cubed. So the cube root of x is equal to 1/4 y plus 6. I'm going to go ahead and subtract 6 on both sides. So we have the cube root of x minus 6 is equal to 1/4 times y. And then to get rid of the 1/4, I'm going to times by 4 on both sides. So that leaves me with 4 times the cube root of x minus 6 is equal to y. And because we multiplied the 4 to both sides, that means we multiplied it to the whole part. So I'm going to need parentheses here. Okay, and the last one, let's start with changing up x and y. So we have x equals the square root of 5y minus 6. To get rid of that square root, we need to square both sides. So we're left with x squared equals 5y minus 6. We'll add 6 to both sides. So x squared plus 6 equals 5y. And then we'll divide by 5 to both sides. So x squared plus 6 over 5 is equal to y. And that concludes the assignment. Thanks for watching, and if you have any other questions, make sure you check with your teacher. Thanks, bye.